guys, so today's lesson is going to be over parallel lines. Let me get this set up. Alright, work with me. Okay, parallel, guys. The word parallel, those two L's in it, kind of is a reminder for you of what parallel looks like. Okay, parallel are two lines that will never intersect each other. Okay, like the railroad tracks. We can find a lot of example of parallel lines in the world. Okay, so parallel, if you ever forget, just look at the word. This is what parallel is right here. Okay, two lines are parallel if the lines have the exact same slope. That's why they never touch. They always either are increasing at the same rate of change or decreasing at the same rate of change. So if two lines have the exact same slope, they are parallel, they will never touch. Okay, so let's go through a few examples and figure out what is this given slope of the line. And then we're going to figure out what would the slope be of a line that's parallel to it. Okay, so on this one, y is by itself. So when y is by itself, we look at the x. Slope is the number that's attached to the x. Well, I have a negative, but remember that's the same thing as a negative 1x. So my slope would be a negative 1. So the parallel slope. I know the slope of any line in the world that would be parallel to this line would also be negative 1. Okay, on the second one, y is by itself, so I look next to the x. My slope is 2/3. So the slope of this line is 2/3, which means any line in the world that would be parallel to this line will also have a slope of 2/3. All right, y is by itself on that next equation. So I find my x. My slope is a negative 3. So any line parallel to that same line will also be negative 3. Okay, on this next one, y equals 5. That's a kind of a strange one. Notice your x's are missing. So that's when we're going to use Hoy Vux. Well, it's y equals, so I know I want to use Hoy. Because it's a y equals equation. Okay, so whenever it's a y equals equation, this middle letter right here is here to remind me of what type of slope it is. I know it's going to have a slope of 0. Also remember, a y equals equation is a line that is horizontal. So I know any line in the world that's parallel to y equals 5 will also have a slope of 0. Okay, this next one is a little strange as well because my y's are missing, so it's x equals, so I'm going to use Vux. I'm going to write it little if I can. So I know an x equals equation, so this x equals 2 would be a graph of a vertical line. And that u is helping me to remember. So I know any vertical line has an undefined slope. So any line that's parallel to x equals 2 will also have an undefined slope. Okay, on this next equation, unfortunately, y is not by itself. So to determine the slope, I'm going to have to get y by itself first. And to do that, I'm going to take away my 3x's first. So my positive 2y's fall down, and on the other side I have 6 minus 3x. Okay, so to get a y by itself, I need to get rid of that 2, so I'm going to divide both sides by 2. Y drops down. Okay, I have a lot of people that try to type this in all together. They try to type in 6 minus 3 all divided by 2. Well, notice, this is a constant. This is a regular number. This number has an x, so these are different. You can't do that. You have to treat them separately. So first, we're going to take 6 and divide it by 2. 6 divided by 2 is 3. Now I need to take my negative 3x's and divide it by 2. Well, I know a negative 3 divided by 2 is a negative 3 over 2. And I can't forget to put my x. Now that y is by itself, I look at my x. Slope is the number that's touching it, so my slope is a negative 3/2. So I know any line in the world that's parallel to this guy will also have a slope of negative 3/2. All right, let's find slope. So we have to solve for y. I'm going to take away an x from both sides. That's going to leave me with 3y equals 9 minus x. If it makes it any easier on you, put minus 1x. So 9 minus x is the same thing as saying 9 minus 1x. Okay, to get rid of that 3, I'm going to divide both sides by 3. My y drops down. Okay, remember, this 9 is a constant. This negative 1 is an x, so they're not the same. You have to treat them separately. So first, 9 divided by 3 is 3. Then I need to take my negative 1x and divide it by 3. Well, negative 1 divided by 3 is a negative 1/3, and I can't forget my x. Now that y is by itself, I look next to the x, so my slope is a negative 1/3. So any line that's parallel to that line will also have a slope of negative 1/3. Okay, so on example 1, we want to write an equation in slope-intercept form, that's y equals mx plus b, that passes through the given point and is parallel to the graph of the given equation. Okay, so I need to write an equation that will go through this point, and I want it to be parallel to this guy. So parallel tells me I want it to have the same slope. I want it to have the same slope as this guy, so I need to identify my slope. My slope is attached to the x because y is by itself. So I want to use that exact same slope. Okay, I don't want the exact same line. I'm going to have a different y-intercept, but I want to use this slope. So if I have this slope and this point, we're going to calculate our new y-intercept value. Okay, so this is an x, this is a y. So y equals mx plus b. So to calculate my new y-intercept for the new line, I'm going to plug in y. Well, y is 12. We want to use the same slope as the given equation, so negative 1/3. The x I want to plug in for my point is negative 6, and I'm going to solve for my new y-intercept, my b. So let's simplify. Negative 1/3 times a negative 6 is a positive 2. My 12 falls down on the other side. To get b by itself, I'm going to get rid of that 2 by taking away 2 from both sides. So that's going to leave me with 10 equals b. Okay, so I know my equation, I want to be parallel to this line, so I want to use that same slope. And if I want it to go through this point, I know my y-intercept will be 10. So let's write an equation with this slope and this y-intercept. So my equation will be y equals negative 1/3 x, and my y-intercept is a positive 10, so I'm going to put plus 10. So this guy will go through this point and is parallel to this line. Notice they have the exact same slope. Okay, on B, I want it to go through the point 3, 2, and I want it to be parallel to the x-axis. Well, let's draw. It's always good to get a visual. We know this is the x-axis. We know this is the y-axis. Okay, so we want it to be parallel to this guy. Well, what type of line is the y-axis? Well, the y-axis is a vertical line, so I'm going to put vux. And any line that's parallel to this guy will also be vertical. So my y-axis is a vertical line. Any line that's parallel to it will also be vertical. So that's why I'm writing vux. Okay, we want to write the equation. Well, I know a vertical line, the equation is x equals, and look at our point. We have to pick the x from our point. So I know x is equal to 3. On this next one, I want it to be parallel to the x-axis. So let's draw a picture. This is the x-axis, this is the y-axis. I want it to be parallel to this guy. So any line that's parallel to the x-axis will also be horizontal. So I'm going to write hoi. So the x-axis is a horizontal line. So any line that's parallel to it will also be horizontal. So if I want to write the equation of a horizontal line, I know it's going to be a y equals equation. Well, y equals what? We have to look at our point. The y value of our point is 9. Okay, on example 2, it says, given the following information, determine whether the lines are parallel. Hint, find the two slopes and see if they match. So remember, to be parallel, they have to have the same slope. Okay, well, lucky us on this first equation. On the first equation, y is by itself, so it's really easy to identify the slope. Just find x. Okay, on this next one, we could identify the slope, but I want to practice solving for y on this one. And then I'll talk about how we could have identified it right away. But just for practice, let's solve for y. So let's distribute. 3 times x is 3x. 3 times 5 is a positive 15. My other side will fall down. To get y by itself, I'm going to get rid of a minus 5, so I'm going to add 5 to both sides. So that's going to leave me with y equals 3x plus 20. So now that y is by itself, I look next to the x. So are these two slopes the same? Positive 3, positive 3, yes, they are parallel. Okay, so how could I have told the slope of this guy just by looking at it? Well, hopefully if you recognize this isn't written in point slope form, remember, one second guys. Okay. Sorry guys, someone was at my door. Anyway, okay, so that equation right here is written in point slope form. So if you can recall, point slope form is y minus y1 equals m times x minus x1. So if you were able to identify that this was written in point slope form, from the very beginning you could have known, hey, slope belongs right here in front of the parentheses. So you could have said, hey, the slope is 3. But if you were not able to identify that that's point slope form, you would have to solve for y, which is what we did first. That's why it's important to know what different types of forms are. That way you can pick the easier route sometimes if you're aware of the different forms and what they look like. Okay, let's see if these two guys are parallel. So line f of x, passes through these 2 points. Line g of x, passes through these 2 points. So I'm going to find the slope of the line f, and I'm going to find the slope of line g, and see, do they have the same slope? If they do, they're parallel. Okay, so let's do line f. To find the slope of 2 points, I start with a fraction bar with a minus sign on top and bottom. We put y's rise. So if I look at this point, the positive 3 is my y, so I'm going to put that on top. The negative 3 is going to drop below it. Next point, y rises. So my y is the negative 4, so that rises to the top. And that negative 1 is going to drop below it. Okay, so if I calculate that, it's going to come out to be a positive 7 over a negative 2. So that's our slope for line F, the one that passes through these 2 points. Okay, now let's talk about line G. Start with your fraction bar with the minus sign on top and bottom. So line G goes through this point, the y rises, so 5 goes on top, that negative 1 has to drop below it. Next point, the y rises, so the negative 4 has to go on top, and this 2 has to drop below it. Okay, so on the top, I'm going to get a positive 9. On the bottom, I'm going to get a negative 3, and that simplifies. 9 divided by negative 3 is a negative 3. Okay, so the slope of line F is 7 over negative 2. Slope of line G is a negative 3. Compare these two slopes. Those are not the same, so those two lines would not be parallel. Okay. On this one, are these two lines parallel? So you could do this one a few different ways, okay? You can, one, look at the two lines and see, do they look parallel? So we know parallel lines will never intersect. Or you see how they gave you 2 points? You can actually calculate the slope if you're unsure. How about we do rise over run, since it's a picture of a graph? Okay, so I know both of them are negative, so that's a good sign. But let's do rise over run. Let's use peak. So 2 points. Look at this line. Here's my 2 points. I'm going to turn it into a triangle. I know it rises 1, 2, 3, 4, 5 squares, and it runs 1, 2. It's going down, so it's negative. This guy, connect your 2 points. Let's do rise over run. Well, it's rising 1, 2, 3, 4 squares, and it runs 2. So it's going down, rises 4, runs 2. That's the same thing as negative 2. Okay, so compare their slopes. These two slopes are not the same, so these are not parallel. And you could tell by looking at it, they don't look parallel. You can see that eventually, it might take a while, but eventually if I continue this line and I continue this line, eventually they would meet out in this direction because they're leaning towards each other just a little bit. Okay, let's figure out the slope of a line that's parallel to the line y equals 2. Okay, well, I see a y equals equation. Notice my x's are missing, so that's a strange one, so I'm going to use that Hoy-Vux to help me remember. So since it's a y equals equation, I know the line will be a horizontal line. So this is what y equals 2 looks like, some horizontal line. What is the slope of a line that's parallel to it? Well, I know a horizontal line has 0 slope. So any line that's parallel to this will also have a 0 slope. Okay, on example 4, I want the slope of a line that's parallel to x equals negative 4. So notice my y's are missing, so it's a strange one. I want to use my Hoy-Vux. Okay, so x equals, that's Vux. So I know an x equals equation will be a vertical line. So this is what x equals negative 4 would look like. It's going to be a vertical line. So x equals negative 4 is a vertical line. So I want a line that's parallel to it. So any line that's parallel to it will also be vertical. Well, we know vertical lines have an undefined slope.